Hello, everybody. We're going to get started in just a minute. We're going to let our participants file in here. All right, we can go ahead and get started. Well, hello, everyone, and thank you for joining us today. This is the first in our four-part series of drones for workplace safety. So I'm super excited to be talking about drones, and thank you all for joining us today. My name is Emily Whitcomb, and I'm the director of our Work to Zero initiative here at the council, which I will tell you more about in just a minute. But we want to give a big shout out to Univar Solutions, who sponsored the drone webinar series throughout the month of September. So huge thank you to Univar, and they will hopefully be joining us at the end of the webinar to say a few words. We're having some technical difficulties on that end, but it happens in this day and age, right? So huge thank you to Univar. If anyone is interested in sponsorships opportunities for Work to Zero, we can post a link in the chat if you are interested in checking that out. So I'll tell you a little bit more about Work to Zero if you're not familiar with our program. We are a grant-funded program here at the council. We're funded mainly through the McElhatton Foundation, and we are really focused on helping employers adopt life-saving technologies. So we are working really hard to create tools and resources for you all to help make innovation a little more accessible for employers. So we have been putting out a ton of resources for you all. If you haven't had a chance to check out our website, nsc.org/work-to-zero, we have web pages of content. We have, I think, 5 reports up there now. We have some technology specific reports, as well as a paper that looks at the top hazardous situations in the workplace, as well as the relevant technology solutions. So check that one out. And we are doing our 5th recorded webinar series on drones, but we've done a series on COVID and technology, about immersive technology, fatigue in the workplace, as well as proximity sensor. So really great content in there if you haven't had a chance. We also recently partnered with Safety Tech AI, which is a really cool website to search through different types of technology that have safety application. So go ahead and check out nsc.org/work-to-zero, as well as Safety Tech AI. I also want to mention we have some events coming up. So in October, we have our NSC Congress and Expo. And we have a big push around safety technology at that event this year. We have a safety technology pavilion with different technology vendors and booths. We also have 3 Work to Zero technical sessions. And then we have additional technology related sessions as well. And then the Work to Zero team will be releasing our digital readiness assessment and white paper. So we're really excited for that new content for you all. And then coming up this February, we have our Work to Zero Summit and Expo. This will be our 3rd summit, which we're really excited to be adding the Expo onto it to really help bridge that gap between our employers that are looking for technology solutions and our technology vendors. So if you've never been to the summit before, it's a very participatory event. We make plenty of opportunities for networking and for sharing of best practices among participants there. So save that date, February 17th through the 18th. We are hoping to be in Kentucky. So let's look at our drone series through the month of September. Today, we're going to kick it off by doing a high-level introduction to drones, talking about what are some of the risks that we're solving for, or what are some of those use cases. Next week, we'll be diving into confined space and other kind of tight places. On the 21st, we'll be talking about the aerial use of drones, and then we'll finish out our series on September 28th, talking about submersible drones, which is a really interesting one as well. So why is drones important? When we did our initial research for Work to Zero, we looked at some of the top hazardous situations that workers were dying. We found the number one cause of fatality in the workplace for non-roadway was working at heights and a worker falling from a height. And when we talk to our safety professionals about technology options that are available to help mitigate that risk, drones came up over and over and over again. So we really identified drones as being one of our priority technologies because of its ability to mitigate that risk for some of our top hazards. So that is why we really felt it was important to talk more in depth about drones today and through the month of September. So this is that report I just referenced where we looked at those top hazardous situations. It is free up on our website, nsc.org/work2zero. If you go to the resources tab, you might have to scroll pretty far down, but it was our first report that we put out. So that's plenty of background information. We should hop into our webinar today. And I want to introduce our speakers. Really excited about today's lineup. I'll have them introduce themselves. We'll go from left to right here. Sarah, do you want to kick us off?
Sure. Thank you, Emily. Hi, everyone. My name is Sarah Crabb. I am with Accenture. I am our Industry 4.0 and beyond practice lead, heavily focused in innovation and leading our industrial workforce, connected workforce, and intelligent asset management practices out of our South Market unit. And thanks for having me.
Absolutely. Mike, could you introduce yourself?
Sure. Mike Pence. I'm the managing director for DECRA North America in charge of industrial inspection. My background in history is 15 years in the power industry, specifically nuclear power. And then I joined DECRA about a year ago, managing their industrial inspections division. So.
Thanks, Mike. We're happy to have you here. And Keely.
Sure. So my name is Keely Griffith. I'm the Director of Industry Education at the Association for Unmanned Vehicle Systems International, or AUVSI for short, which is essentially the world's largest industry organization dedicated to the advancement of unmanned systems. We participate or drive a lot of these conversations about the intersection of safety and advanced technologies, largely because we have the ability to leverage cross-domain expertise and lessons learned. We engage pretty heavily in education, both of regulators about the value that these systems can provide, and about to the public about safety, but most importantly, just to broaden the discussion around UAVs to include not just existing uses, but the entire range of possibilities from automation.
Great, thank you, Keely. We're really happy to have you here as well. So we really want to make sure that our audience is able to get engaged with the conversation. So we would love if you all took the opportunity to introduce yourselves in the chat. And just a quick Zoom tip, when you open up your chat, you'll have to switch it to all panelists and attendees so that everybody can see who's on our webinar today. If you could introduce yourself, your name, your company, what's your interest in tech, maybe share some of your experiences with us if you've been using drones or if you are looking at using drones. Also, we'd love to know how Work2Zero can support you, if there's specific information you're looking for, if there are tools or resources that the Work2Zero team could put together for you all. We are here to create resources for you. So it's always really helpful for us if we know what you all need and what you all are looking for. We will also have opportunity at the end of our moderator discussion for audience Q&A. So if you look up on your bar, there should be a button that says Q&A. You can click that, type your questions in there. You're also able to upvote questions. So if somebody else asks a question that you are really interested in, upvote that. We usually start from the top down with the most popular questions as we're rolling through our Q&A. So with that, I see lots of intros in the chat here. Thank you, thank you. It's always great to see who's joining us, what industry they're from. I think that really can help our speakers tailor the information that they're sharing, the use cases that they're sharing. So really excited to see that engagement there in the chat. All right, let's kick over to our first question. And when we do our intro webinars, so our webinar series, we kind of like to look back and see how this technology evolved and where it came from, how it's changed. It helps us kind of figure out where we've been and look at where we're going to go, which the future of drones is a question we'll have a little bit later. But Keely, it would be great if you could kick this one off for us.
Sure. So how have drones changed throughout the years? There's sort of two components to this. First is a military evolution of drones, which dates back to the early 1900s, some even say into the later 1800s, but much of the research and development work was done for decades in this space. That said, military advances in the development of these new technologies informed commercial applications, which I think is more relevant for this conversation. So the second component, the commercial evolution, at the sort of in the early phases, the use cases mimic that of the military. So surveillance, inspections, and security. But in a report that was recently just put out by the Enos Center for Transportation, Ken Dunlap specifically mentions the development of compact stabilization systems, autopilot technology, high-speed electric motor controls, and high-density batteries, which all help to reduce the size of these systems and eventually led to the development of small UAS. Additionally, the ability there to link UAS with GPS satellites improved navigation. And with this sort of plethora of advancements, small UAS can now be produced at large volumes and through the commercial supply chain. There's some additional research out there that will highlight sort of the important stages of the evolution for drone technology, but they largely center around reliability and improved equipment. So more reliable controls and stable flight capabilities allow small UAS to become a reliable and predictable tool that can be integrated into sort of everyday operations. This includes sort of the additional automation advancements in technology because it simplifies the operations, and then a larger group of pilots can then utilize the systems. Additionally, upgrades were made to cameras and sensors on these tools, and this leads to improved images and reports. The systems then act as like a data collection tool. So it improves the accuracy of the data collected, and it becomes a great use case for aerial surveys and inspections that are being conducted. So I think that that's sort of phase two. When you think about scalability, it's something that we're still working towards, but with the improvements in accuracy and precision, there is now this great use case for real time. Like, how can we collect this information in real time, improving the effectiveness and efficiency of operations? And then we're still seeing developments in data management and machine learning, which will help to integrate these systems even further in, because as organizations are collecting this tremendous amount of data, it's okay, what are we going to do with it? How do we make it actionable? So these algorithms look a little bit different based on the industry that it's being used within, but the principles still remain the same. And I'm a huge advocate for learning from other verticals on how they're using the systems, because it could inform something that you're doing within your own industry. So through the proper integration of these systems, it becomes more routine. And I think that it can either pose the systems can be either pose an immediate or obvious risk, or address an immediate or obvious risk, or something less obvious. So I think like the long-term exposure to certain chemicals or different fumes and things, so you can use these systems to detect those things, which again, improve workplace safety. So.
Yeah, thank you, Keely. And these are definitely systems that are getting more and more advanced, what feels like every day. And Mike, you shared with us a story earlier about your work in Chernobyl. I would love if you could share that with our attendees here.
So I spent about 3 years working out at Chernobyl, running a major project. And it was just interesting being there, everything, the culture, and then seeing all the things that they still have. Like, they had a display of all the robots that they used to help clean up the accident. So you have 35 years ago, and they hired several companies in Europe and Germany to design these big bespoke robots, tracked, treaded mechanical devices to go in and try and clear rubble and push things into the reactor and just help clear the scene, reduce the radiation risk or exposure to the personnel. And it was just interesting seeing these things. Most of them, actually, when we talked to the people who operated them and who were on site while they were operating, who were still working at the plants, said they weren't very good, actually. They broke down. They had a lot of difficulties covering the terrain. They were designed and they got there, and there was an explosion, there was debris. They didn't work as good as they had worked in the field testing, so they couldn't predict the conditions, along with the radiation, the heat, and other things that were going on. Now I think about what Boston Robotics or Boston Dynamics is doing, and with their robots. I think they recently had one of their dogs actually out at Chernobyl walking around the site. They could access it. They could put sensors on it. They can put telemetry on it. They can do SLAM mapping. You can put, the new Ilios drone has the new radiation monitoring technology that they just released. You could put that onto it, fly it around, could have taken the dose measurements. It's just you think about the dose and the lives that, possibly could have been saved, but just the technology wasn't to that point yet. And now you're seeing it where we're really just pushing the boundary and things are really advancing quickly out there with what's going on today. So.
Yeah, thanks, Mike. And that's a really good, both you and Keely get a really good kind of preview of some of the advancements, what drones can do for us. But, as safety professionals, I'd love if we could take a step back and really talk about what are some of the risks that the drone technology can help us mitigate. And Sarah, I'd love if you could kick this one off for us. Oh, there you go, Sarah. I think your line is muted. Keely, do you want to talk to this one while Sarah figures out her technical difficulty there?
Yeah, absolutely. So, I mentioned before, it's really important that you're sort of learning cross verticals, because I think the use cases are there from a number of industries. So you'll see it pretty heavily in construction, in mining. You think of infrastructure inspections. That's where you're going to see a lot of the more predominant use cases of these systems right now. And it's largely because you're keeping that human out of some of those dangerous situations. And I see that Sarah's off mute, so I wanted to give you the chance to jump in.
Sorry about that, y'all. Something weird is happening. Tech is not always perfect. We all know that. So drones really can help mitigate quite a few risks. A range, and we started off with, we talked about heights, and I can get into that in a minute and specific areas around that. But the ability to utilize drones in other aspects, whether it's looking at inspection across, hundreds of miles of pipe in, say, a Permian or, different utilities or whatnot. That actually, what that does is that actually decreases the time that workers have to spend in the field, and that travel time, which is very dangerous time, because they're traveling between sites, they're on long hours, sometimes very difficult environmental type of things. So reducing that, it actually helps reduce the number of safety related incidents that happen, which is a big thing for companies right now. If we get into heights, we can really look at, from if I break it down, serious injuries, fatalities, and workforce exposure to, things like harmful chemicals can be reduced utilizing drones and with cameras and different sensors to detect gas leaks. Where traditionally you would send out a worker to go and measure that. Some other serious related incidents or fatalities that occur from manual work inspections can really be reduced or eliminated altogether. Some of those are around like power line and transformer inspections. You can utilize drones now and also integrate that in with the GIS system that the company has of where the asset is, and sensors that are on those transformers, or in order to also get to a predictive state. From a wind turbine, wind is very big right now. We're hearing more and more about it. Wind turbine inspection has been historically manual. People have to climb up these large poles. There are certain safety components that they have to take and lock in order to get up these. You can use drones now to inspect these wind turbines, whether there's cracks, defects in the rotor, the tower foundation. You don't have to put individuals at risk anymore when doing that. Drones are also being used, not necessarily from a height standpoint, but in, kind of hotspot areas. For instance, firefighters and emergency and police forces are actually utilizing drones now to provide their workers situational awareness, but before they even approach or go into a burning structure or fight a forest fire or something like that. So that's very, it's ranging. I've actually worked with clients very heavily on utilizing drones so that their individuals don't have to climb cell towers or walk along scaffolding inside giant tanks of a plant to collect visual data. That can all be done now by drones, which ultimately reduces that worker time at a hot spot or a very height, and it allows them to focus on other tasks at hand. One of the biggest things is reduction in confined space entry time. So we've talked about this. This has been a fairly hot topic over the last 4 or 5 years, is reducing workers' confined space entry time, and drones now allow you to do that. So there are different types of drones, different form factors of drones, and you have a lot to choose from.
Definitely. I mean, and from a service industry perspective, we've heard of our service partners doing, like you said, police and firefighters. So with the police, they've done, one of the things, we'll work with a local police department, and they'll break a window, and we're able to fly one of our interior drones into the inside of the structure to allow them to see through the structure before the personnel actually enter. We've seen people doing lighting inspections at football stadiums where the lights are up in the rafters and they want to make sure the lights don't fall down onto the spectators. So we can take certain drones and we can fly them up and inspect the fastening points. So that way somebody doesn't have to climb out through roped access or put up scaffolding to do those types of inspections. And with the wind turbines, yeah, of course, one of the big breakthroughs we're seeing from a service perspective is, the drones, of course, doing the inspections of the delamination or cracks on the structures, but also you have the lightning protection systems, which even if you do the drone currently, I think all the technologies, if you do the inspection remotely with the drone, you still have to test the lightning inspection and somebody still has to climb up there. Well, there's new technologies coming out now where they're able to basically put a reverse signal through the lightning protection system, send the drone up, and then the drone can detect the capacity or the intactness of that protection circuit still. So there's definitely some major developments that are still coming out.
I think it also helps organizations sort of get ahead on those, I'll say, the structural degradation of systems. So if you have these systems and they're doing continuous inspections or ongoing inspections, it helps an organization get ahead of any problems that could occur. I know that you mentioned that height isn't the only risk. I know that that's a great use case for these systems, but it also keeps individuals from coming into contact with toxic chemicals and emissions. Sites where there's a lot of moving machinery, especially large machinery, that puts individuals at risk. Situations where there's heavy traffic or high speeds, and then some of that high voltage equipment, all of which are great use cases. You can dig into those specific industries. I think mining specifically, because there are like the blast sites and they can be really dangerous following a detonation, and the land becomes really sort of unstable, and there's all these additional hazards for materials and ground to those personnel. So if you can dispatch a drone and collect some aerial data that can be used and collected for that post-blast inspection to ensure the site's safe before anyone else continues to work, then, again, another great use case. I know that a lot of rail companies are now using these systems to check for wear and tear on the track, as well as vegetation that may be getting in the way of a track, and rocks, and even security. BNSF has been utilizing these systems since 2015, and they have found that it's helped to supplement their bridge and check and yard inspections as a mean to add to the inspection frequency. So it's not many, many years before something gets looked at without adding human occupancy to sort of those assets. So.
Thank you. Lots of great use cases here. We were talking with the panelists before we started the webinar about just all the different types of uses, different industries. So we tried to set this webinar series up to dive into some of those different uses for our most hazardous situations. And we also tried to bring a variety of speakers to you all so that we can talk about uses across different industries. I'm going to switch us over to our next question here. I want to remind the audience, if you could pop any questions you have in the Q&A after our moderated questions, we will have an opportunity for audience Q&A. So our next one here, kind of a two-parter. We wanted to talk about other types of safety technology that could be used with drones. And also, what are some of the best practices in integrating some of these different types of technology? So Mike, do you want to start us off here?
Sure, certainly. I mean, that's something we're seeing more and more common is the integration of different sensors, technologies within the drone. So it's not just a drone platform, but it's what else you can do with that drone platform. I think that just to take off where Keely left off with the mining, you look at the SLAM mapping. So simultaneous location and mapping, I think it is. Sarah will fix me if I said it wrong. Where the drone can self-pilot itself down through a mine and check what's going on in the mine. You don't need a pilot. You don't have to worry about somebody crashing it. It automatically, using a LiDAR sensor and various optical sensors, will fly in and can look at that. And then you can also attach thermal cameras to it to get thermal sensors, thermal imagery. The LiDAR scanning, you're right now we're starting to see an increase of LiDAR scanning used with photogrammetry to basically make 3D models of structures, components, systems, whole power plants. So if somebody wants to make a model of their asset with details about what's the structure look like, where is their degradation, you can use that LiDAR scanner along with other various sensors to do that. One of my favorites being from nuclear, and we're now thinking about, is radiation sensors. So, from a use case of, like I said, Flyability just came out with their radiation sensor, which has a live mapping where you can map and see, in real time what the radiation is at various points, and you can track the flight path and the time, and you can go back and look at in your flight time data where you saw a radiation spike and what could be the problem with that. We're thinking about use cases on that with like the DoD and their depleted uranium fire ranges. People have to go out and hand survey those. Can we have an autonomous drone that schedules its flight, flies the whole range with a radiation sensor looking for particulate debris that's left out there? It just keeps coming. Maybe I'll invite Sarah. She's on the cutting edge of what else is going on. I can only talk about some things that we've read recently.
Yeah. So, as far as other safety technology goes, I think you kind of covered it from a high level standpoint. There are different types of cameras. You get a drone, and there are many different types of drones that you can get, and it depends on what you're trying to do and the use cases you're trying to solve for, and kind of what that environmental factors are also play a role into what you're going to get. The different types of cameras that you can affix to the drone, whether it be a regular camera that can be used to complete or assist with just inspections on construction sites or just gather visual information. There are thermal cameras that you can affix that can relay information, for unknown hazards that could be present. They can sense heat, and they can help really inform responders about the environment. There are also, a lot of different types of sensors that can be affixed. There's a plethora of sensors, and everyone always like, well, can't I have it all? And you don't want to have it all. That goes with kind of the integration and how do you go about doing this, and we'll cover that I think next. But you can have anything from LiDAR to sensor, which illuminates, a target with a laser light, and then it measures that reflection to create the data points in order to map the area. And we're actually using that quite a bit across a ton of different verticals to map the facilities and the construction areas to create 3D renderings that feed into our digital twin models, which then allow us to start looking at real-time kind of insights and start to apply our algorithms and AI to look at predictive and then eventually prescriptive. So that is just one of the, one of the enablers. Then you have the ability to collect, have multispectral data, which is collected by different sensors that measure the reflected energy. You have hyperspectral data sensors that really measure energy in a narrow and with more numerous bands than multispectral. And that's typically used from an aerial standpoint. And then you have other sensors which can be used, which I know Mike touched on, to detect radiation, say in a nuclear power plant from an inspection standpoint. And then you also have sensors that can look at detection for thickness measuring for inspecting industrial assets. We've used that quite a bit in our plants to measure thickness of a wall inside of a coker unit or a boiler. So
definitely.
Yeah, and then
that one with the UT sensors. I mean, that's become an interesting thing that we've seen, some requests for, is that UT sensor on a drone. Can you fly up and test just the thickness of my wall, or can you test this? Right now, we have thermographic sensors that we can put on climbing robots that can climb up and around aircraft frames and check, and it basically heats up the surface and checks for delamination. And what else can we do with that drone? Can we take that delamination, that thermographic sensor, and put it on? I mean, the hyperspectral imagery is really interesting as well. We do nuclear reactor vessel head inspections. That's not a flying drone. That's a driving kind of, looks like a wheeled crawler that we drive in remotely. And we're testing with with EPRI right now the use of that type of hyperspectral imagery. Can we see more about the composition of the metals? What's going on? Is it degrading over time, or is it still intact? So those things are it's real. It's out there. It's kind of interesting what's been coming out recently.
It really is. And one of the things I don't think I did touch on is all the other different types of gas sensors that you affix to drones. We're running drones and services with clients and programs to look at different types of gas emissions and methane detection, whether it be above ground, underground, and that also combines technology. So we're doing that quite a bit from an onshore and offshore, looking at degradation of utility assets in the field and whatnot through drones instead of deploying workers. But I think what's really interesting, and this is not a safety technology per se, but what really has enabled the ability to get this data in a real time, near real time, or even just a faster manner in general, is the edge devices and edge capability that we have. And everyone edge has been around for a while, but it's being used in different ways, and depending on what you're trying to achieve and what you're trying to measure and detect, that will depend on whether you need access to your data once a month, once a week, near real time, or real time. And so the ability to have these edge devices, which allow you to get this information from all these different sensors at the edge and have access to that analytics, real-time insights to be able to make better decisions, that's huge. And that is actually one thing that's being done. Edge devices are being attached to these drones. So, and we'll talk about in a minute, it's not just about the drone. You have to be able to get the data, the imagery, the sensor data off of that drone ingested into a software platform or into the cloud and get those analytics and to be able to have insights and make better decisions. And attaching these edge devices to the drones in some scenarios is a really popular route to go down. I think that we wanted to, if I'm going to hand over to Keely and see if y'all want to touch on anything else before we go into kind of best practices for this type of stuff.
Sure. The only other piece that I think that I would mention is the magnetometers. So they've been proven really effective for mapping mineral deposits, which can be used in engineering and environmental projects. So I just think that that's really relevant, especially for those that may be in oil and gas and are doing inspections around pipelines or other buried infrastructure. And then there's obviously, and this is probably maybe would be a good segue into that next question. But what about the types of technology and softwares that need to be integrated into the drones that make them a safe option? So you can't just introduce a new technology and think that that's going to solve all of your workplace safety problems. We actually have to utilize and implement systems that will create those safer operations. So sorry, Emily, if I launched into that next question.
No, and actually, Keely, that's a good jumping off point for one of the questions in the chat was in regards to how do you introduce these types of systems safely so that you're not causing other hazards in the workplace. If you all want to run with that one, that would be great.
Sure. Yeah, Keely, you can start. I'll jump in. You know, I'm very passionate about
yeah,
this.
I will say very carefully. It is not a, hey, let me go out and buy these systems and then figure out how to use them to save my organization money or to sort of eliminate the risk for my workers in the space. I would say that there needs to be proper planning, proper procedures and processes and training that needs to be done. In fact, UAS operations require trained pilots. So you don't want to trade one risk for another. So before you implement these technologies into your program or regular operations, consider the importance of those safety requirements that your organization needs to follow. The Center for Transportation report that I just mentioned, and it literally came out September 1st, I encourage you to read it, there's a heavy focus on sort of this safety framework or safety culture. And commercial operators present a higher level of risk and requirements need to be tied to a larger safety cultural framework. This is something that AUVSI is really passionate about, and it actually led to the creation of our Trusted Operator program, which is made for commercial remote pilots, and it complements their current regulatory compliance by adding elements of safety culture, best practices for operations and procedures, documentation, airmanship, human performance, codes of conduct, automation awareness, risk management systems, and some technical, like non-technical skills that need to be included for your pilots. They have to be trained at the appropriate level of risk for the operations that your organization is trying to introduce. And then, and this really should be developed in partnership with stakeholders in the industry. And, there's obviously a lot of training out there, and I encourage organizations to just be aware, especially those leading the organizations.
I couldn't agree more, Keely. And so, I mean, one of the things that I experience almost on a weekly basis is with our clients is, drones will solve everything. They're shiny and new. Everyone wants to have them. Everyone wants to use them. And it's kind of like we're using them. They just want it. But there are so many other technologies out there that can be used in parallel with drones to achieve digital transformation and increase an organization's digital maturity. I think what clients tend to underestimate is the foundational layers that they need to have in place in order to start a program around drones. And there's things that need to be put in place, and that, such as you need to have well, maybe not right away, depends on the size of the organization and what they're trying to achieve, but you need to have a stakeholder group, you need to have alignment, and ideally down the line, a center of excellence stood up. You need to have, cross-functional teams, which are made up of members of different parts of your organization, because I have several clients who they actually have drone initiatives going on in 8 different parts of their organizations, and none of them talk to one another. And there's so much overlap that is happening. And that is really kind of a waste of time and money and resources. You also, companies really underestimate what it takes to have certified flight instructors that have meet all the training requirements, that have the hours in place, the processes that go around or that come with, scheduling a drone flight, complying with all the FAA processes and regulations, the time it takes, all the permitting, all of that, even though the regulations have been loosened a little bit over the last year and a half or so, they're still there. So there's a lot to do. And so companies underestimate that. So working with your SI and the ecosystem and services companies really is important to bringing that all together, because they are experts in their areas and what they do. We went back to a drone is a drone, but being able to get that data out, having that, whether it's at the edge and ingesting it into a software platform and getting your analytics off of that, you have to think about all of that, because data is just data at the end of the day. You have to be able to make something out of it. And then, so
I just wanted to compliment something that you were talking about. It's using those systems and following sort of the FAA's guidelines. I mean, that's a must, but drone pilots can use platforms like Skyward, and they can launch that within minutes, and then use the FAA's automated LANC approval process. And then from that, you can see temporary flight restrictions, coordinate safe flights with others who might be flying drones or their aircraft in the area. And we say it often, it's not just a know before you fly for the recreational community. It's really important that you make a plan for your operations, for your larger business operations. And I imagine that for most organizations, the idea of risk management is sort of the pressing matter here. And so as you're evolving the integration process, think of things like the traffic management systems that you can integrate in, coordination with manned aviation, and then other techniques that your organization can use to mitigate these risks. And so some things that I'll mention, applications like AirMap, like Skyward, drone software, those are critical for having the information that you need to enable safe missions.
Exactly.
I want to add just a little something from a service perspective. Is I completely agree with everything that was said there on the how do we implement this safely? Training, more training, experience. Once you feel that you've trained, experience. I mean, as a service company, we still turn down jobs. We're asked to fly drones in areas or plants, and we say, look, we don't have the experience to do that, but here's another company, or here's a service partner that we have that has that type of experience. Because the worst thing you can do is go and create a liability, for your client or for somebody else that doesn't previously exist, whether it's, introducing foreign material or an additional risk or hazard of something falling on people. That's really, a training experience procedure. There should be a procedure for how you activate and operate. And that, I go back to the training, like you said, the FAA training, so the drone training itself, the training on how to use the sensor or the equipment that you're attaching to it. So if you're going in to do UT thickness scanning, do you understand what you're seeing or radiation detection? So you have to have those trainings as well. And, going kind of what Sarah said about the shiny new drones, certainly, I mean, from a service division perspective, we have my R&D team bring me different shiny new things, and definitely have been burned by saying that looks really cool, let's buy it. And we get it and we go to our clients, we say, hey, we bought this cool thing. And they say, yeah, so did we. So, understanding and working with your client, as you're integrating new technology, you have to do that. And you have to understand who your client is, what your market is, where you're going to deploy it. And and if you don't do those things, then you're not going to be successful. I mean, we've had cases where from lack of training and lack of maintenance, like even maintenance and training of drones, you have to understand how you're going to maintain that drone. We in one of our continents, we lost $100,000 in equipment because of maintenance. They didn't maintain it. They didn't know how to maintain that equipment. And then inexperience of flight, they flew it in places that they didn't have the experience of doing, even though that they might have had the 2 weeks of training on how to do that flight. So those are all important aspects you have to look at when you're implementing the technology. It's not just buy a drone and bring it. One guy in a van, he shows up and brings it off the shelf. There's so many aspects.
Right.
Yeah, thank you, Mike, for building on that. And Sarah, I wanted to respond to that earlier. So the new resources that Work to Zero is going to be releasing just next month talk about digital readiness and what you need to do with your organization to get ready. So it's really meant to be kind of a conversation starter within your organization if you're looking at innovating. Because like you said, you can't just go out and buy a drone and now you have the successful drone program, right? There's a lot of things that need to be put in place and done internally before that type of change. So we'll be releasing that, I believe at the end of October, or I guess mid-October at our Congress. But I wanted to shift this over. We only have about 12 minutes left in the webinar. I want to talk about what the future looks like, but I also will need some time at the end. We want to give Univar a few minutes to say hello. But let's talk about what the future of drones looks like. And Keely, I think you're going to kick this one off for us. And then Sarah, in the past, we've talked about, what 5G looks like. So I'd love to touch on that as well, knowing we'll probably have to scoot through this question a little quicker. But Keely, do you want to kick us off?
Yeah, absolutely. So in addition to, I think you'll see a focus on increased training. It's largely going to be in response to the scaling of how you'll see drones integrated across industries and verticals. There's going to be a lot heavier sort of reliance on these systems moving forward, just from decreasing sort of those safety risks that we've sort of talked through, as well as improved efficiency. But the future of drones, there's going to be a tremendous focus on autonomy. And developers like Skydio are investing heavily in automation and autonomous technology, which really allows for more efficient and safer operations. I know that they specifically employ 4 UK cameras to their drone, which allow for that real-time 3D mapping, the object and scene recognition, motion planning, and then 360-degree obstacle avoidance. You're going to see more and more organizations that are starting to develop, and they consider themselves sort of a software company that also happens to build drones. So you're going to see a lot more of that integration moving forward.
Yeah. We are a very much tech agnostic firm, obviously, because we are a very large firm. We work with all of the ecosystem partners, whether it be Skydio or any others, but I think that what they're doing, it is moving towards more towards autonomy. I think that layering in this whole, with the advent of 5G networks, I think it's really going to unleash a future for drone technology, which will drive innovation across industries. 5G is the next generation of mobile networks. It's extremely low latency with high-speed connections. It'll provide more efficient technology, higher data rates, and spectrum utilization to cope with that growth of the mobile data traffic and new applications. So if you all think about and remember all the examples we talked about earlier in this call, where workers have historically been put in dangerous environments, and now we're starting to utilize drones, but there is a manual component to drones still at this point in time. With the 5G network, the drone could be automated, meaning there is no need for a pilot or person controlling the drone. Enhanced cameras and videos could provide the real-time analytics to help navigate and maneuver that drone to a more precise place. And they'll be able to collect harder to reach surveillance data. And what's really interesting as well is that because 5G provides video streaming that is much more clear, it's much more accurate and reliable than Wi-Fi. And so you're not going to have the disruptions or interruptions. Additionally, you have the ability to have a privatized 5G network that will be an added benefit to companies. So I'm happy to talk about that more on a side if anyone wants to understand that. We actually just put in the first 5G privatized millimeter wave network in our Houston living lab. And just what I've seen with that in respect to the use cases that for our clients is absolutely, it's insane. We're seeing 100 times faster speed, the ability for like 10 times more connected devices. We're seeing less than 10 to 50 milliseconds in latency. And we're seeing more reliable and predictable performance. So it is just really impressive.
Correct. I mean, from a service perspective, I think autonomous flying, AI, and data analytics, those are the three things that we're focused on for the future. The autonomous flying, you can cut inspection times down 20%, down 80% to 20 to 25%. We're seeing, wind turbines. We're looking heavily at, autonomous inspections of those offshore over in England is one of the projects we're working on. It saves the owner of the asset money. They can run the wind turbine longer. They don't have to shut it down as long for us to do the inspections. We can get in, we can get out, we can reduce time at sea, the risk for the personnel. And that autonomous, you don't miss wind turbines, you don't miss blades, you don't have misinspections. The AI that can, simultaneously read the data, tell you what the important inspection points are. Hey, I don't need to watch 20 hours of inspection footage where an inspector gets tired and misses a crack. The AI picks it up and he's now reviewing 5 minutes of crack that the AI has picked up. And the data analytics, there's so much data, but you want to make it, for managers and decision makers, you want to have that data available on a platform somewhere where they can access it, see what the critical decision, the key points are. They don't want to know about 1,000 wind turbines. They want to know about the 20 that they have problems with them, and what are the trending problems that they need to have so they can correct those before they happen to the others. So that's, for us, I think that's really where we're focusing on the future.
And I think to round it out is companies need to be aware of where they're going in the future and what they want to tackle. And it shouldn't just be around drones. It should be collection of data from other types of sensors and inputs. And so creating an architecture and a framework around that to be able to collect data from all these different sources and then receive analytics and gather meaningful insights from all of that data is very important, because the interconnectedness, it's great just to have information on drones, but what about everything else? Tying it all together, that's going to be very important. Create that framework, make sure you spend time up front around, that enterprise architecture. And so there, I'm going to stop and turn it back.
Oh, that's fantastic. This was such a great discussion, and I want to give a big shout out to our attendees here who have been popping questions in that Q&A. With a lot of our discussion, I think we've touched on many of these. Some of them I'll bring back to our remaining webinars in our series, but really great engagement from our audience. So really appreciate that from you all. I do have some closing slides here I'd love to share, as well as give Ben from Univar an opportunity. If you didn't hear us up front, we had some technical difficulties in the beginning there. So Ben, if you are able to unmute and say a few words, I want to give a big thank you to you for sponsoring our drone webinar series.
Absolutely. Can you hear me?
Yes, you're good.
This is great. I mean, I just want to thank you guys for putting this on. This information and this technology saves lives. For us, Univar Solutions in the chemical industry, we utilize drone technology to evaluate emergency response situations with thermal imaging, like the panelist said, determine if a scene is frankly too hot for humans to enter that space, could compromise, building, tank integrity, things like that. And we also use it for significant traffic incidents to preserve scenes, the integrity of the evidence. So that's been a big thing for us too, across the transportation sectors. So I don't think we can call this emerging technology anymore. It's here. It's not going anywhere. We love it. So again, thank you for putting on the webinar. I'm looking forward to what we have next. But again, this is truly a content segment that saves lives, keeps people safe.
Yes, thank you, Ben, and thank you to everyone at Univar Solutions for making this webinar series possible. As I close out here, just a reminder, if you haven't checked out our resources, nsc.org/work2zero, everything is free, downloadable. You can also check out all the recorded previous webinars that we've done, and then also check out Safety Tech AI to browse some different technology options. And make sure you are signed up for the remaining webinars in this series. So next week, we'll talk about confined space entry and other tight spaces. Then we'll talk about aerial drones on the 21st, and then we'll close out the series talking about submersible drones. And I think on the 28th, we're also going to give you all a sneak peek of our digital readiness assessment and white paper that we have coming out. So make sure you get registered for all of those. Even if you can't attend it live, if you register, you'll get a link to the recording. So it's a good reminder for yourself to go watch the webinar later when you're able to. And you can find the registration at nsc.org/work2zero, and it is under the resources tab. So with that, I want to say thank you to everybody for joining us today. We had a great number of panelists, or I'm sorry, a great number of attendees. Very excited about that. And also a huge thank you to our panelists. This was such a great conversation. I knew it was going to be, so really appreciate all of your time and expertise and volunteering to share that with us today. So huge thank you to you all. And with that, I'm going to close this out. You will get a prompt to take a post-webinar evaluation. We would love to hear your feedback. If there's things that we could do better, please let us know. We want to make these webinars as good as possible for you all. So we appreciate that feedback. All right, everybody, I hope you have a good rest of your day and a great week. Thank you all.
Thanks, Emily.
Bye.
Thanks, y'all.
Bye, everyone.